Energy means the capacity to work. The resources used to work are called energy resources. The demand for energy doubles every 14 years, and so the consumption of energy is considered as the parameter of progress.
India, with only 16% of the world population, consumes only 1.5% of the total energy produced in the world, in comparison with USA, which has 6.25% of the world population and uses 33% of the total energy. In 1998, the World Resource Institute found that the average American uses 24 times the energy used by an average Indian. Even today, almost 80% of the Indian population depends on fuel wood, dung and agricultural waste as sources of energy for cooking food.
Energy is an essential input for industrial development. Energy is produced from commercial sources like coal, petroleum, hydroelectric projects, as well as from non-commercial sources like cow dung, wood fuel, and agricultural waste. India's per capita consumption of commercial energy, that is energy from coal, petroleum, and hydroelectric energy, is very low. It is only 1/8 of the world average.
In India, commercial energy accounts for a little over half of the total energy used in the country, the rest coming from non-commercial sources. The share of agriculture in commercial energy consumption has rapidly increased in the past 4 decades. Industry consumes 80% of the coal and 70% of the electrical energy. The transport sector accounts for 65% of the total oil consumption. The consumption of the household sector has also increased due to the use of air conditioners, refrigerators, and other electrical appliances. Now, India has to not only increase the indigenous availability, but also aim at efficient utilization of the energy resources.
Energy generation and environmental conservation are the twin issues that arise due to the exploitation of natural resources. A 1987 report of the International Energy Agency contains a simple but remarkable statement. Investment in energy conservation at the margin provides a better return than investment in energy supply. That means conservation of a unit of energy is cheaper and environmentally more desirable than generating an additional unit. Actually, generation of every additional kilowatt hour of energy requires an investment of rupees 7,000 to 12,000 in the form of new energy generation equipments.
Excessive utilization of coal and oil for generation of electricity leads to multiple problems like global warming and acid rains. Tension also prevails in the Middle East since its huge reserves of oil deposits are sought after by other countries.
To reduce dependency on coal for generation of electricity, hydroelectricity power stations and nuclear power plants are advocated. Huge dams can contribute significantly to electricity generation, but they inundate forests, farmlands, and wildlife habitats. Entire communities of indigenous people become homeless. Harsud in Madhya Pradesh is a very good example. Its population was displaced due to the construction of a dam on the Narmada River. People who had lived there over generations found themselves to be refugees in their own land. Nuclear power plants come with the risk of radiation leakage, which result in diseases like cancer and birth of crippled children.
Between 1950 and 1990, the world's energy requirement has increased 4 times. By 2020, it is estimated that Asia Pacific region will consume 40% more energy than North America.
Classification of energy resources: non-renewable or conventional resources and renewable or non-conventional resources. Non-renewable or conventional resources are formed once in thousands of years, hence they are on the verge of getting exhausted. Example: coal, petroleum, LPG, and radioactive elements. Petroleum is expected to get exhausted within 30 years, LPG within 50 years, and coal within 100 years. Renewable or non-conventional resources. These resources have a cycle, hence they are non-exhaustible. Example: solar energy, wind energy, hydroelectricity, biogas, petrocropping, petroplantation, thermal energy, and tidal energy. These sources are discussed one by one. Coal. For about 2000 years, coal was the primary energy source. It fueled the Industrial Revolution in the 19th century. It is used directly in furnaces or converted to electricity in thermal power plants.
Coal is a fossil fuel formed when trees got buried inside the earth in the absence of oxygen. Carboniferous period of Paleozoic era, about 80 million years back, is considered as the golden age of green plants. At that time, the carbon dioxide content in the atmosphere was 0.04% or 400 ppm as compared to present day, which is 0.03% or 300 ppm. As a result, the trees attained large size, for example, Lepidodendron. It is estimated that the earth has deposits of almost 6,000 billion tons of coal, of which 2,000 billion tons have already been used up.
Coal deposits of different countries are coal is mined from the earth. In India, coal mines are found in Jharia, Bokaro, Giridih, Karanpura of Bihar state, Raniganj, Barjora and Darjeeling of Bengal state, Godavari Valley of Andhra Pradesh, Singrauli and Korba of Chhattisgarh, and Suhagpur, Pench Valley, Umaria and Lakhanpur of Madhya Pradesh, and Chanda, Kamti, Umred and Bhanded of Maharashtra. Even today, coal meets 37% of the energy demands at world level. It is one of the prime sources of energy. It is also the source of phenyl, ammonia, naphthalene and coal gas. Coal has the following adverse environment effect. It contributes the maximum emission of greenhouse gases, leading to global warming. Burning of coal results in the emission of sulfur dioxide and oxides of nitrogen, which cause acid rains. Acid rains kill forest vegetation, damage historical monuments, pollute water, and affect human health. Thermal powerhouses produce fly ash, the dumping of which is a problem. These days, fly ash is used to prepare cement as well as bricks. Mineral oil. Petroleum is popularly called liquid fossil. It was formed when aquatic animals and marine algae got fossilized. That is why oil wells are mostly found in the sea.
Due to heat and high pressure, the fat of animals got mixed up with minerals and petroleum was formed. Saudi Arabia, Mexico, USSR, Iraq, Iran, Kuwait, UAE, Bahrain and Qatar have deposits of petroleum. In India, petroleum deposits are found in Bombay High, Gujarat and Assam.
According to Britannica Book of the year 2003, the petroleum deposits in various countries are At present, the Gulf countries are the greatest oil exporters. In fact, their economy runs on the petrodollars they earn. In India, ONGC, Oil and Natural Gas Commission, looks after the survey of petroleum and gas deposits. Petroleum is considered a clean fuel for automobiles, but its drilling, refining, transport and utilization have serious environmental consequences. Oil slicks and cleaning of oil tankers and shipwrecks pollute seawater as lot of oil floats on the surface of the sea. Sea animals and marine algae are disturbed. In 1989, a huge oil carrier, Exxon Valdez, sank due to accident, and a large quantity of oil was seen floating on the sea surface, killing birds, sea otters, sea fish, and other marine life along the coast of Alaska.
During the Gulf War in 1991, oil wells were bombarded and plenty of oil could be seen floating on the sea surface, disturbing marine life. There was also black snowfall in Kashmir, and when this snow was analyzed, it was found to be rich in hydrocarbon, proving that this was due to the oil pollution in the Gulf countries.
Dependence on oil resources results in political tension, instability and war. At present, 65% of the world's oil reserves are located in the Middle East. Other countries desire control over these countries to gain access to the oil wells. This results in war. Oil-powered vehicles emit sulfur dioxide, carbon monoxide, nitrous oxide, hydrocarbon and particulate matter, causing the problem of photochemical smog in big cities. Leaded petrol emits lead particles in its white smoke, which causes neurological problems, whereas unleaded petrol contains benzene and butadiene, which are carcinogenic. LPG or natural gas. LPG is gas fossil. GAIL, Gas Authority of India Limited, looks after the survey of this gas. LPG is also popularly known as cooking gas. It is odorless and clean and a convenient source of energy to be used as domestic fuel. From Bombay High and Gujarat, a pipeline runs through Rajasthan and MP, Hazira, Bijaypur, Jagdishpura. The gas pipeline is 1,730 kilometers long. It transports about 18 million cubic meters LPG per day.
Along with cooking, LPG is also used to produce electricity. It is also used as a raw material in the fertilizer industry. In 1988-89, the total production of LPG in India was 27 million cubic meters. In 1999, the quantity of usable LPG was 692 million cubic meters. Most of the natural gas in India is linked to oil, and because there is no transport system and also because there is a shortage of storage cylinders, most of this is just burnt off. Thus, about 40% of the gas is wasted.
A histogram showing the availability of natural gas is as shown. Radioactive elements. In 1938, two German scientists, Otto Hahn and Fritz Strassmann, demonstrated nuclear fission. They bombarded the nucleus of radioactive element uranium atom with neutrons and succeeded in splitting the nucleus of uranium, resulting in the release of tremendous energy. This gave birth to the idea of nuclear power industry. The first nuclear power plant was started in 1957 in Pennsylvania, USA. Dr. Homi Jahangir Bhabha is considered as the father of nuclear power development in India. BARC, Bhabha Atomic Research Center, Mumbai, is connected with the research on nuclear technology. 1 kilogram of uranium produces electrical energy equal to 3,000 tons of coal. India has nuclear power plants at Tarapur in Maharashtra, Rawatbhata, Kota, Rajasthan, Kalpakkam, Tamil Nadu, Kakrapar, Gujarat, Kharwar in Karnataka, and Narora in Uttar Pradesh. They meet just 5% of our electricity need.
The central government wants to start 6 more nuclear power plants in different states in the country. India gets uranium-235 from Singhbhum at Bihar and Rajasthan. This uranium-235 is made into rods. Neutrons are bombarded on these rods. Fission of uranium takes place and energy is released in the form of heat. This heat converts water into steam, which drives the turbines, and electricity is produced. Thus, fission of uranium-235 is used to create and generate electricity.
The drawbacks of nuclear electricity are uranium ash is formed and its disposal is a problem because this ash is radioactive. Previous practice was to seal it in thick crucibles and dump it into the sea. But after a few years, the seals are damaged and the released ash is absorbed by the sea vegetation and fish and can enter the body of man and harm not only the present generation but also the future. Because radiation causes mutation in gonads and the children born may be crippled.
A new suggestion is that this ash should be dumped in holes drilled in rocks and then sealing the rocks. But this can prove to be dangerous in future when these sealed rocks crack open.
In 1979, the nuclear plant in 3 Mile Island in USA and in 1986, Chernobyl in Russia had to face leakage problem in nuclear reactors, resulting in the loss of numerous human lives and causing disease like cancer. In 2011, Japan was hit by a tsunami and 4 nuclear power plants out of 6 developed the problem of leakage. The reactors had to be closed.
In this part of the program, we discussed about the non-renewable or conventional sources of energy. In the second part of this program, we shall be taking a look at the non-conventional or renewable sources of energy.